Before we start, we will give you exactly 30 seconds to try answering this on your own, together with the questions that can be found on the right-hand side of your screen. If you think you need more than 30 seconds, you may pause this video before the start of the discussion. If you think that you don't need the 30 seconds, you may skip this video to the portion of the discussion. Your 30 seconds starts now. Now here, it gets trickier. Look at the terms found on our binomial. We have coefficients for both terms which are not equal to 1. We have here 3x and 2y. Whenever you're going to expand this binomial expression, you need to really consider the correct exponentiation of the coefficients. Now let's start the expansion by understanding the number of terms that could be drawn from the expansion of this binomial expression. We have here n equal to 6, which corresponds to the exponent of this binomial. This would mean that the number of terms is n plus 1, which is equal to 6 plus 1, 7. So in our expansion, we need to have 7 different terms. And these terms will be patterned on the correct coefficients according to the Pascal's triangle. At the same time, the correct exponentiation of the terms. We'll do it step by step. Actually, here in our 3 different questions, we already answered 1. How many terms are there? And this is again important before we start. But the next 2, the 5th term and the numerical coefficient of the 3rd term, can be answered once we are done. We expect to have 7 different terms. So by Pascal's triangle, we have 1, 1, and 1. We have here 1, 2, and 1. We need to approach the row with 7 coefficients so that we could write the correct coefficients for the expansion. We have here 4, 1, 4, 6, 4, 1 is 5. We have 1, 5, 10, 10, that's 10. Another 5 and 1. This is still 6. So we have the last one, 1, 6, that's 15, 20, 15, 6, and 1. We'll be using this row here. The terms or the coefficients here will be the coefficient of the term when we expand this binomial expression. So it will look like this. I do hope we have a lot of space here, but if we don't have, please bear with me. We'll have 1. So we have here plus 6. We are using addition. Don't worry about that. We are using that for easier processes later. But of course, if there are negative results, we will have to use the negative sign. But I believe we don't have negative sign here because the operation here is plus, or the sign of the coefficient of y is positive. We have here plus 6 and we have here plus 1. So we have 7 different terms using this 7 coefficients. We are going to start expanding this by following the process of the decreasing orders of the exponents for the first term and decreasing order for the exponents, increasing exponents for our second term. It will look like this. In the previous videos, we were able to really look at the pairs, but since we don't have much space here, let us start and do it at once. You have here 1 as your coefficient, and you have here your first term, 3x. Raise it to 6. It's not just a 3, it's not just x, but it should be the complete term, while your 2y will be raised to 0. Okay, because it will start with 0 for the second term, while the highest would be for the first term. You have here plus 6, and then your 3x will now decrease with its exponent 5, while you are going to increase your 2y. That's 1. Next, plus 15. Your 3x becomes 4, with the exponent of 4. Your 2y will have square plus 20, okay, times 3x raised to 5. Sorry, 3 rather. And you have here your 2y raised to 3. By the way, here's the hint so that you will be guided with what your steps are. Look at the exponents: 6, 0, 5, 1, 4, 2, 3, 3. If you're going to add each pair of exponents, it will go back to your n. If something else is not 6, then that means your process is incorrect and you need to review that. Just like here, 15. Of course, we expect 3x to become 2 because it's in decreasing order. So without any other analysis, your 2y needs to have 4 so that it will reach 6. Same as here. You have 6, your 3x will have 1, while your 2y will have 5. And finally, I don't know if I still have spaces here, but let me just continue. 1, your 3x becomes 0, while your 2y becomes 6. So I still have space here for the answer later. So this is why I don't need to share here each pair just like in the previous videos, because this is very long. So this is 1, this is also 1. Any expression raised to power 0 is 1. So we have here 3 to the power of 6. So you have 3 times 3, that's 9, times 3, 27, times 3 is 81, times 3 is 243, times 3, that's 729, x to the power of 6. Okay? You might want to use your calculator for this, but let me just show you the rest of the process here. 3 is again 243, right? X to the power of 5 times 2y, okay, plus that's 15 times 81 if I'm correct, right? X to the power of 4 times 4, that's 2 squared, y squared, plus 20 times 27 x cubed. So you would see that your result, this 8, is very large. This is because your exponent is large and you will have coefficients here not equal to 1. This is why this binomial expansion is very time consuming, but it's very important to make use of the correct answers or coefficients. Like here, 9x squared, and the 2 becomes 16 y to the power of 4 plus 6 times 3x, because that's to the power of 1, times 32 y to the power of 5. That's 5. Let me rewrite it. 5 plus, of course, that's 1, is also 1. 2 to the power of 6 is 64 y to the power of 6. So let's try to multiply this. I don't know if we could do this mentally, but if you can, you may use your calculators there. 729 x to the power of 6. You will have here plus. So just for the purpose of this, let us use calculator here. Okay. Just for the purpose of faster multiplication, 6 times 243 times 2 equals 2916 x to the power of 5, and you have y plus the next you will have 15 times 81 times 4, 4860. You will have here 4860 x to the power of 4 and y squared. Again, notice the exponents of the variable 6, 5 and 1, that's 6. 4 and 2 is 6, so it will reach the same here. So that's your hint. Followed with, you will have 20 times 27 times 8. You have 4, 3, 20. You have 4, 3, 2, 0, x cubed, y cubed, plus another one here. So you have 15 times 9 times 16. That's 2160. 2160 of x squared y to the power of 4 plus. So look at this one. We have addition, right? It would be even harder if we have negative signs here. But of course, try to do it step by step. 76 of x y to the power of 5 and plus finally 64 y to the power of 6. So this entire very lengthy expression is the expanded form of this binomial expression raised to the power of 6. So the fifth term, 1, 2, 3, 4, 5, this is the entire fifth term. You will have 2160 x squared y to the power of 4. And the numerical coefficient of the third term, this one here, is 4860. So again, it will take us a lot of time, but this is the correct process and the correct answers for the expansion of this given video. So if you would like to view the last video provided here, or the next video rather, please continue in subscribing and share these videos to help others as well. Thank you very much and goodbye everyone.